Today we're going to talk about radical functions, specifically two types of radical functions, because they really fit in with the inverses that we talked about yesterday. So the first one is going to be the square root function. And what that would look like would just be the square root. We are going to have our a, h, and k like we've had in previous functions, like our quadratics. So that is something that we will add later. But the most basic square root function is just the square root of x. We also have the cube root function. And what that looks like is almost the same as the square root, but you have this little 3 right there. And that's called your index. So that's how you tell the difference between a square root and a cube root or any other root. We could have a fourth root of x or the fourth root of anything, but we won't worry about graphing those. Now, how these are related to inverses, think about it. When you solve a quadratic function that has a second power, you take the square root of both sides. You're undoing the square. And remember, we talked about how inverses are undoing something. So you have a second power or a squared term, you take the square root to undo it. So it's the inverse of a quadratic. And the cube root is the inverse of a cubic function or a function raised to the third power. So when we graph these, like I was saying, we are going to worry about our a, h, and k. And our standard form is y equals a, and then we'll have the square root of x minus h plus k. And a, h, and k do the exact same things as they've always done for us. Remember, h is your left and right. Left or right. K is shifting up or down. And that a value will give you your shrink or stretch. So let's see if we can squeeze that in there. Shrink or stretch. And also the reflection if you have a negative number in front. So the parent function, we have that up here. It's just the square root of x. I usually call it the mother function instead. But it's just a square root of x, and then we shift that or transform that based on our a, h, and k values. Now, the domain of the standard form of our square root function is 0, infinity. And the reason for that is because we got to remind ourselves that domain deals with x values. You can't plug in a negative value and take the square root of that. You can't take the square root of a negative number. So that's why the domain of the parent function is 0, infinity. Now, if we shift left or right, that could change our domain. But basically, without any shifting, your domain is 0, infinity. Your range is also 0, infinity. Think about it. If you take out your calculator and you take the square root of any number, are you going to get a negative answer? And it's no. You cannot you cannot take the square root of any number and get a negative answer. So that's why your range has no negative numbers in it. Remember, ranges for y values. So you can't have a y value smaller than 0. But like I said before, you can always shift up, down, left, or right, and that would change your range. The basic table that we're going to use to graph these square root functions is going to be 0, 1, 4, 9. and the y values 0, 1, 2, 3. I know this may not make sense that your x values are going up the way they are, 0, 1, then adding 3 to 4, then adding 5 to get to 9. But the reason why we're using those x values in our table is because you can take the square root of each one of those numbers and get a whole number answer. I don't have 2 in my x values because I take the square root of 2, I'll get a decimal. And then your graph would look something like this: 0, 0, 1, 1, 4, 2, and we can't fit 9, 3 on here, but we will have that one normally. So the square root function looks like that. And that should look a little bit familiar, because if we were talking about a quadratic function or a parabola, a parabola would look like this. And if you just get rid of like half of it, well, we kind of just rotated that or reflected this green line to get our blue line. Then the cube root function, standard form again, is going to be the same thing as we have above, except it's going to be the third root of x minus h plus k. And your parent function is, or mother function is, the third root of x. Now, the domain and range of a cube root function for both of these is going to be negative infinity, infinity, because you can take the third root of a negative number. Watch, I'll get my calculator out, and I could do the third root of negative 8, and I get negative 2. So yes, I can take the third root or cube root of a negative number, and I can also get a negative answer. So the table that we're going to use for cube root functions is these x values, and then the y values would go like this. The reason why, again, we're using these x values is because you take the third root or the cube root of these numbers and you get whole number answers. So then your graph, negative 2, we're going up by 2's here. So 2, 4, 6, 8. So this graph would look like this. That's how a cube root graph would look like. So this is going to be very crucial when you are graphing these, because this is where you're going to start from. You're going to look at this type of table, and then you're going to transform it using our A, H, and K values. So this is something that you should always have out when you're doing your assignments. All right, let's graph these. So first, what I want to do is I want to do our comparison. And remember, the comparison, that is where we do the RST. So R for reflection. Well, our A value is 3. That is not negative. We have a positive A value, so there's no reflection. Shrink or stretch, we do have a vertical stretch by 3. Translation, we are translated right 1 and up 2. And again, the way we know that is we have a minus 1, so that's going to be going right 1. And then this plus 2 on the outside means we're going to go up 2. And this is our A value. So the first thing we're going to do is we're going to make table for the mother function. Okay. So I'm going to do that down here because I want to be able to write step 2 above this. Oops. So this is a square root function. And we're going to go with our mother function, which is 0, 0, 1, 1, 4, 2, 9, 3. The next step is you're going to add a row and multiply y values by our a value. So what we'll do is we're going to add another row underneath, and we're going to call this 3y because we're going to multiply all the y values by 3 because that is our a value right here. So 0 times 3 is 0, 1 times 3 is 3, 2 times 3 is 6, and 3 times 3 is 9. So then the next step is going to be graph. Well, how do you know what to graph? We have x, y, and 3y in our table. We cross off our middle row. So we're going to ignore that. We're going to plot the points 0, 0, 1, 3, 4, 6, and 9, 9. So here's that graph. Well, then you have to account for the shifting, the right 1 and up 2. So the very last thing we're going to do, our fourth step, is to move points right 4 and up 2. Sorry, not right 4, right 1 and up 2. And we're getting those numbers from our translation over here. Right 1 up 2, right 1 up 2. So all of my points that I have in orange right here, I'm going to go right 1 and up 2. Right 1 and up 2. Right 1 up 2. Right 1 up 2. So my actual graph of this function is my purple line right here. So when I'm asked about domain and range, I'm going to ignore my orange line and focus on my purple line. This point right here, where my graph starts, is 1, 2. That is going to affect our domain and range. Domain, again, is x values. My x values start at 1, and they go all the way over to positive infinity. Okay, because we don't have any purple line over here to worry about. Now the range, the y value here is 2. We don't have any y value smaller than that. So 2, infinity is our range. And end behavior, well, we only have one end of this graph. We usually would have a left end and a right end. We don't have a left end. You don't see any arrows pointing to the left. You only see arrows pointing to the right. So that is why we will only have, as x approaches positive infinity, that means right side. Well, is our y values going up or are they going down? Our y values are going up, so y approaches infinity. So this is a lot of steps that you need to be able to organize in your work, so that way you're able to graph these correctly. So don't try to skip any steps, because then you are going to try to have to look back and fill in what you skipped. So these are the steps you need to follow when graphing these. All right, let's look at the next page. Example number 2 is a cube root function. So let's start with our comparison. There is a reflection. You have that negative in front of the 1/2, so there is a reflection over the x-axis. So reflection over x-axis. Shrink or stretch, we have a shrink by 1/2. Translation, we are translated left 2 and down 3. Left 2 because you have a +2 inside the radical symbol, and a -3 tells us that we are going down 3. So we're doing the same thing that we did with the square root function. The first step will be to make our table, but this is a cube root function, so we have to use that cube root table from the first page. In the cube root table, the x values went -8, -1, 0, 1, and 8. And the y values were -2, -1, 0, 1, 2. So then we're going to add that third row, and it's going to be 1/2 y. So we're going to take our y values and multiply them by 1/2. -1/2. So -2 times -1/2 is +1. -1 times -1/2 is +1/2. 0 times anything is a 0. +1 times -1/2 is -1/2, and 2 times -1/2 is -1. So now I'm going to plot those points. Remember, we're going to cross off the middle row like we did on the square root function. So we have -8, comma, +1. We have -1, comma, +1/2, 0, comma, 0, 1, comma, -1/2, and 8, comma, -2. So the original function cut. So the untranslated function will look like this. And now we need to translate this based on our h and k values, our left 2 and down 3. So we're going to move each point left 2 and down 3. Okay, so each point left 2, down 3, 1, 2, 3, right here. Left 2 and down 3. Left 2, down 3. Left 2, down 3. 1, 2, right here. Left 2, down 3, 1, 2, 3. So this will look like that now. So that is our given function, that pink line. Now the domain and range of a cube root function always going to be -infinity, comma, infinity. So these should be free points when I ask you about them when it comes to cube root functions. Domain and range is always -infinity, comma, infinity. Now, end behavior. We do have two ends to talk about. We have an arrow going to the left, and we have an arrow going to the right. So we will have, as x approaches -infinity, that's the left side. Well, the left side is going up. It might be hard to see because of how slowly the y values are going up. But if we take our pencil and start moving to the left, look at the y values are going up very, very slowly. So y is going towards +infinity. And as x approaches +infinity, y is approaching negative infinity. So that is your end behavior. So it is going to be a little challenging at first, remembering, okay, square roots have only one end behavior, cube root functions have two end behaviors. Example number 3. All right, let's do our comparison, our RST. I notice that this is a square root function. So there is no reflection because we don't have a negative number in front. There's no negative sign. It's just a positive 3. Shrink or stretch. We have a stretch by 3. Translation. We're not shifting left or right anything because we don't have a plus number or a minus a number inside the square root. That minus 6 is outside the square root, so that means our shifting is going to be down 6. We're not moving left 6 or right 6. So our shifting is just down 6. All right, so let's make our table. Our square root tables go 0, 1, 4, 9. And then the y values 0, 1, 2, 3. Our third row, we're going to take each y value and multiply it by 3. So 0 times 3 is 0, 1 times 3 is 3, 2 times 3 is 6, and 3 times 3 is 9. So now I'm going to graph my points, but remember crossing off this middle row right here so we don't accidentally graph those. So 0, 0, 1, 3, 4, 6, 9, 9. So here is our graph before we do any moving. Now we're going to move each point down 6 because that's what our translation is. So each point is going to go down 6. Each point down 6. 2, 3, 4, 5, 6. So now when I look at my domain and range, I want to look at that green line. So domain, let's label this point right here, and maybe in a color that is easier to see. 0, negative 6, because that starting point right there is going to help us figure out our domain and range. So our domain is going to be 0, infinity. The smallest x value we have is this 0 right here. Now the range is going to be negative 6, 0, because negative 6 is that smallest y value we have. And then end behavior, we only have a right end. So as x approaches positive infinity, that means the right side is going up. So y approaches infinity. That is our only end behavior for this. Now with number 4, what I'm going to do is I'm going to start you guys. I'm going to put the table in. And I'll have you guys do the comparison, domain, range, plot the points, and do the end behavior. So our table, since it is a cube root function, our table is going to look like this with the y values. And I'll even start the third row for you guys. There's nothing there. There's an invisible 1, so you can have 1y. Now, technically, do you really need to make that third row? No, you don't need to do that third row, but I know that doing it will help you in the long run, where you're just in the thought process of just making that third row. Even if your a value is 1, yes, your y values will not change from the second to third row, but it's about getting that practice of doing that. So I'm going to leave it here. Fill in these values down here by multiplying your y values here by 1. Then graph it. Do your comparison, domain and range, and move all that. So pause the video, finish this problem, and when you're done, unpause it so we can check the answers. All right, so this is what you should have gotten. The domain and range, like I said, should have been easy because the cube root, your cube root functions will always have this domain and range. So hopefully, because you did not have an a value, this wasn't too difficult to do on your own. You just need to remember to move your points right 2 and down 4. So the more you do this, the better you will get at this. We're going to practice it a little bit more. I hope that you are getting more comfortable with this though. So thank you for watching this video. Make sure to smash the like button and subscribe.